Hello. Getting to 300 million requests with a one-man AI DevOps team without going broke. I want to start by telling you about the worst day of my professional life. This is what my feed looked like on January 2nd, 2024. We just crossed 6 million monthly users and hundreds of millions of requests per month. And before these messages were coming through, I was confident, even a bit cocky. Every January 1st, a huge influx of new users joins the app as part of their New Year's resolution to read more. The first week or two of the year, really just those first few days, is when the majority of our growth happens for the whole year. In 2022 and 2023, our active user numbers doubled during just those first few days. We were ready. I told my co-founder Nadia that we would be happily playing VR ping pong on the night before our company's biggest day. We would be relaxing. I was wrong. We would not be playing VR, we would be drowning in a sea of requests, unable to keep our app up, unable to keep our head above water. So what happened? How did we get here? To answer that question, we need to go back in time, all the way back. I need to tell you about how I was raised. My mother was a supportive, loving parent who genuinely convinced me that I can do anything. She believed in me, and so I believed in myself. She made me not just want to do well, but to be the best, to be the first in everything I did. Whenever I struggled, she would look me straight in the eye and say, "You can do anything. Remember, you have wings on your feet." And she still tells me this today. At dinner the night before giving this talk in October at NDC Porto, I said, "Mom, if the talk doesn't go well and people start booing, I need you to be the first person to stand up and start clapping for me." And she said it again. I'm 41 years old and I'm still hearing it. That won't happen. Remember, wings on your feet. She first told me this after I lost a particularly tough race. I ran track, specifically the 400-meter dash, and in track, there's a term for what happens on the last straightaway. It's described as death. It's a horrible feeling where you've given the race everything you have and there's just nothing left. If you tell another track runner that you died in a race, they know exactly what you're talking about. I took my be the best mentality into every single race. The popular saying, "I'd rather die on my feet than live on my knees," to me was, I'd rather die trying to run 45 than live with 47. I never felt like I was a particularly skilled runner, though. In fact, my teammates would constantly complain. "Rob, I beat you all the time in practice, all the time. Why are you so much faster than me during the race?" The thing my teammates never put together is that after the race, every race, I'm the only one on the ground throwing up. So my answer? I have a high threshold for pain, and with my mother's belief in me fueling my steps, I was able to turn that belief into gold medals and eventually a full track scholarship to a Division I university. But that deep belief would be challenged in just a few short years when, in college, it hit me for the first time that maybe mommy was wrong. Maybe I couldn't do anything. You see, I always wanted to be a video game developer, and I was told that the route to get there was through computer science. Want to play games for a living? You can do it. We show you how. Page 34. From page 34, this quote, "Nothing is really work unless you would rather be doing something else," said Sir James M. Barrie. He was wrong. Some people get to work in the game industry. End quote. Another quote, "Do your work with your whole heart and you will succeed because there is so little competition. Without a devastating amount of drive and dedication, there is no place for you. If you're setting out to work in video games, you better be sure you want to do it because it really isn't easy. There are probably as many unfinished projects and people with a great idea for a game on the fringe of the game business as there are wannabes with unfinished screenplays flouting around Hollywood." End quote. This last quote, "You have to know computer languages, particularly C and C++, very well. Knowing assembly is also a huge plus. We see a huge number of resumes and a degree stands out. Particularly, if you don't have a degree in computer science, you will need some strong evidence that you can code as well or better than someone who has a degree." End quote. So that's it. Drive, dedication, and a computer science degree. These were the messages drilled into me while growing up, and it sounded amazing. I had to be a part of it. And the path was clear. I knew I had the drive and the dedication. I just needed the computer science degree. So I chose the college with the best computer science program I qualified for, and I gave it my best shot. I was young, excited, eager to prove myself, but there was one major hurdle in my way: math. I worked my butt off to grasp these concepts, but I just couldn't do it. The math was too much for me. I mean, this isn't exactly what I had in mind when I wanted to be a computer programmer. So I went to the IGN boards, the Internet Gaming Network message boards, and I started a new thread. Do I need to be good at math to be a computer programmer? Hoping that maybe there was another way, another path forward. But the answer was unequivocal. Yes. So just like that, at the age of 19, I gave up my dream. Mommy was wrong. I couldn't do anything. I majored in economics and moved on with my life. 18 years later, something was missing. Though I graduated with an economics degree, I spent my entire career in tech. I was in the industry I loved, but I wasn't doing satisfying work. But I did have hobbies, many hobbies. I played basketball every day, I learned photography, I learned Blender, which is an open source 3D rendering tool, and I used it for fun projects like designing our living room in 3D before buying any furniture. But none of these really grabbed my attention. And then one day, a friend gave me a ride in his Tesla. He didn't just show off how it handled the road or how fast it was, he actually talked me through the technical aspects, including autopilot. Using nothing but cameras, it was able to map out the entire environment in real time, accurate enough to drive a car. It blew my mind. Suddenly, I had a feeling I hadn't felt since my childhood, an excitement, a wonder, a pull. I didn't know exactly what I wanted to do, but I wanted to be a part of this AI world. When I got home, I did some research into AI, and I discovered the popular deep learning class from Fast AI. It was thoughtful and well-designed, and I loved the instructor, Jeremy Howard, and his teaching philosophy. They talk about teaching kids AI like learning how to play soccer. He said if you teach a young kid how to play soccer, you don't sit them down with math books and do the physics of all the angles of how to get the ball into the net. You just buy a ball, you buy a net, you go to the park, and you kick it around. And he said that's how you should learn AI. So in the very first class, you're already learning how to create models, and by the time the class is over, you will have one ready. But after taking the course, I felt a bit lost. I didn't have a next step, a clear way to build on that introductory level knowledge and find my place in this new AI world. I didn't have any real-world data to work with, no real-life examples in a way that could make a real impact. So while I was excited about starting my journey, it stalled, and I had nowhere to go. A year later, I had a catch-up call with my friend, Nade Odunayo, and I asked a question that would change the trajectory of my career. See, she'd built an app called the StoryGraph to help people track their reading, and she'd been slowly but steadily growing it. I wanted to know how things were going, so I asked, what's the biggest problem you're facing with StoryGraph right now? She described how StoryGraph is an app that helps you pick a book based on your mood, but categorizing books by mood manually was a long and arduous process. As a result, only 2,000 books were listed on StoryGraph, and in a world where millions of books were published every year, that just wouldn't cut it. Immediately I thought, this is my chance. This is the moment I've been waiting for. AI would be perfect for this. Within a few weeks of that call, using nothing but the knowledge gained from that Fast AI course, and really just that first class, I had a model in production. We were now able to classify books by mood in just a few seconds. I kept improving the model, trying different techniques that I learned, and learning new strategies along the way. And I was having the time of my life. This is what I'd always wanted out of a tech career, a chance to build something challenging and to solve a real problem. I worked on a StoryGraph for months outside of my day job, and soon I was ready to quit my 9-to-5 engineering job. In February of 2020, I joined StoryGraph as a co-founder. I built models for the StoryGraph that turned weeks and months worth of tedious work into mere seconds, and I kept finding new and interesting ways to integrate AI into the product. We built a recommendation engine and would create what we called personalized preview, which analyzes your preferences and reading history to determine if the book you're looking at is a good fit for you. I was building features used by millions of people that leveled up the product and blew our competitors away. But here's the thing. Just like with running, I never felt particularly skilled at AI. I just have a high threshold for pain. I expressed this during our early Instagram AMAs where I said, I don't think I'm particularly smarter than anyone else at this stuff. I just won't quit. I'll happily sleep with my laptop in bed waiting to see how an experiment turned out. Maybe an expert would have solved this in 10 hours and it took me 100, but that's okay. We will win because I'm willing to put in that time. It will get done, and no one's going to try harder than me. My mother always told me I can do anything, but the power behind that statement is in the understanding of why. Why is it that I can do anything? The why is, I will put in the time, I will try harder, and I will be on the ground throwing up. I will keep going, and most people are ready to quit. It's not that I'm uniquely talented, it's that I'll keep going. And if you want to figure out how to get to 300 million requests as a one-person AI DevOps team, you have to keep going, no matter what is thrown at you. But a big part of this that I can't ignore is the role of luck and timing. We happen to have this problem at the perfect time, when there was a crossover between GPUs and hardware just being cheap enough and the software just being advanced enough that someone sitting at home on their personal machines could build models that outperform the state-of-the-art models coming out of research labs just a few years earlier. The open source libraries and tools were simple enough to use that someone without any prior experience and no fancy PhD or Stanford degree can take a free course like Fast AI and get something off the ground very quickly. I was lucky first, so I can then put in the work and use my drive and perseverance to take our company to the next level. But here's the thing. That same luck applies to everyone sitting in the room right now. With the resources we have available, the tools and technologies accessible to us, we are all experiencing the good fortune of timing. We can all build on that luck of being skilled and being alive at the right time to build something great. All you have to do is seize that opportunity and not let go. And that's my first lesson on getting to 300 million requests a month with a one-man AI DevOps team. Take advantage of the luck you're handed. We've leaned into every free open source tool and technology that was available in DevOps and in AI. We learned the new technologies and iterated as needed, leveling up and taking advantage of the progress made by so many other researchers and technologists. We're all living in exciting times, and those tools and technologies are getting faster and cheaper. Take advantage of them. But let's get back to how the worst day in my professional life happened. You see, 6 months later, we would end up having our very first outage. June 11, 2020 was a big day for StoryGraph. We reached a major milestone, 1,000 registered users. To celebrate, we posted an over-the-top story to Instagram with party music, strobe lights, flames. We were excited. We'd spent the last 6 months building on the principles that got me started, releasing many more machine learning models, and improving on the old ones. We were doing great, and we were happy with our progress. 5 days later, a tweet from someone in the community started to gain traction. And over the span of just a few days, we went from 1,000 users to 20,000 users. And that's when the site went down. And people were angry. These are the principles we strongly held to in building StoryGraph. Do things that don't scale, and don't build it until you need it. Don't waste time worrying about how to manage 1,000 people simultaneously clicking the generate recommendation button when nobody wants your recommendations yet, and nobody knows you exist. Well, that time had passed, and now we needed to learn how to scale up and fast. We ended up being down for 2 weeks. And to be clear, most of the app was up, but the main features which were driving people to the StoryGraph were down for 2 whole weeks. That's a really long time in the tech world. Here are some of the lessons we learned which helped us get out of that 2-week outage and kept us ahead of the curve all the way up to the worst day of my professional life. This is a simple and obvious one looking back, but as someone without a tech degree and formal training, I just wasn't sure how to handle this. The Ruby on Rails app has Sidekick, which is awesome, but I'm just running Python scripts with custom machine learning models. How can I manage this when I need to scale up to many, many servers, all taking various machine learning jobs without them stepping on each other? If you aren't familiar with this problem, the first thing you might think of is the equivalent of a watch folder. This comes from a popular video editing workflow that I've used in the past, where your Python script will check a local directory for a file to work on. That file might be a recommendation request, for example. And if it finds the file, it runs that file through the machine learning model and places a new file with book recommendations in another folder when it's done. Sure, if you only have one server processing recommendations, that might work just fine. It's reliable, and if the process crashes, the files will be right there for you to try again. But what happens when you have 2 servers, or 8, or 50? Now you need to, what, sync the watch folder across multiple machines, or set up a network file system so everyone's looking at the same files? Let's assume you could set up the sync with 0 latency, or let's go one step further. Instead of your local file system, let's use cloud storage like GCP to host the files. What happens when 2 servers pick the same file to work on at the same time? Well, when we tried to implement this as an easy, let's just scale to a few servers without getting too complicated solution, I had the idea to have the servers fight for the file. Each server had 3 rules. Step 1, grab the file. Step 2, upload an empty file with the same file name and the exact timestamp that you grabbed that file, down to the millisecond. Step 3, wait 5 seconds and see if anyone else uploaded a similar empty file. If not, delete your file and process what you grabbed. If step 3 came and there was a conflict, all servers involved would go into fight mode. They would all compare their timestamp with the others, and whoever had the lowest number wins. Don't do that. It's not good. Next, I said, okay, these are all just APIs, right? Well, let's use a load balancer. So I set up 8 servers, and anytime anyone requested a recommendation, the request directly went to one of those servers for processing. This is the solution that was live when we hit the 20,000 users, and it failed. Since these requests took about 30 to 60 seconds to run, if more than a handful of people a minute requested a recommendation, they were met with an error. No servers are available. Clearly, I needed a proper queuing system, and surprisingly, it wasn't as complicated as I thought it would be. Redis, a sponsor of this conference. It's what powers Sidekick, and it's one of the standard queuing systems on the internet. I was afraid of adding yet another database system that I wasn't familiar with to our stack, one that I would have to manually interface with, unlike with Sidekick, where that's managed for you. But really, it was easy. Here's the code to add an item to the queue, and here's the code to listen for an item to be added to the queue. And that's it. That command right there, brpop, is smart enough to keep all of your servers in an orderly line. You can have 100 servers all running that command, silently waiting for an item to be added to the queue. As soon as an item is added, it directly goes to the first server in the list, and the rest of the servers just move up their place in line. No fighting required. My journey of finally getting to queues as a solution here is a perfect example of how I operate as an engineer. I didn't figure it out because of a computer science degree. I had no technical training. In fact, if I did have some formal training, I probably would have gotten there much faster. But being a self-taught engineer, my biggest asset was my relentless desire to figure out problems no matter how little knowledge I was starting with or how long it took. The technical takeaway for this was the power of queues. But the lesson here is that if you don't quit, you figure it out. And I always end up figuring it out. The next technical lesson here was the hardest one, but it might be the biggest game changer. The cloud is a trap. When your app is small, using the cloud can make a lot of sense. You can get up and running quickly. You don't have to worry about managing servers. You really can just focus on your code. The sales pitch is true. The cloud can replace your DevOps team. Scott Hanselman, our opening keynote speaker, mentioned in one of his talks that a Heroku slider replaced his entire early career. You used to need a dedicated team to do something like add 10 servers to your cluster. Now, it's just a slider. When I started my career in tech, it was normal for a tech company to have their own server room in the office. It was loud, heavily secured, and freezing. The cloud changed all that. And this can work out great for your app until you need to grow. We got started on the industry standard Heroku, and if you've built a Ruby on Rails app in the last decade or so, there's a good chance this is the service you used. Boot camps were literally teaching on Heroku, and graduates didn't have any exposure to anything else. Let's consider a standard Ruby on Rails app, as we had it set up when StoryGraph started to grow. Web server, database, Elasticsearch, and caching. We had 3 Performance L servers for $500 a month each. The standard rule for Postgres is to have enough RAM to hold your entire database. Our database at the time was around 500 gigs, so standard 9 at $5,800 a month. This was the biggest deal for us because StoryGraph is a very database-heavy app. We need to have good write performance for Goodreads imports and general usage with thousands of people adding books to their to-read list, updating pages read, etc., all simultaneously. And we need to have good read performance with many heavy join queries running for each page load. This was one area we couldn't go cheap on. For Elasticsearch, we simply went up the ladder until we had an option which didn't slow down the site, which ended up being their most expensive option, $1,086 a month. And from Memcached, we had the standard 1 gig plan for $66 a month. For over $100,000 a year to run that app, and our revenue at the time was $30,000. unsustainable. But what choice do we have? Are we really going to go back to having a server room like at my first tech job back in 2005? I did a deep dive and I found a few viable options for us. Home labs have a lot of advantages. You get the exact hardware you want, it usually gets cheaper over time, but there are a lot more real disadvantages. Power outages, internet outages, and you have to do all the maintenance. Before I started hosting services from my house, I thought back and I genuinely couldn't remember the last time we'd lost power. Well, 2 weeks after hosting some critical machine learning infrastructure in my home lab, we lost power, and some StoryGraph features didn't work, so the power came back on. This one removes all or mostly all of the disadvantages of your home lab. Co-location has a lot of advantages. You get the exact hardware you want, it usually gets cheaper over time, there are no power outages because there's redundancy. There's no internet outages because there's redundancy. You may not even have to do all the maintenance. Some companies can do minor hardware swaps for you for things like hard drives or memory. They also have better security. I once visited a co-location data center and it was like I was entering the NSA. There were security guards and a double door where the first door had the lock before the next door opened before I could enter the real room. And 3, dedicated servers. This is the holy grail for me. You get all the advantages of co-location and you don't have to buy the hardware. When you rent a dedicated server, they just give you an SSH prompt, and that's it. You take care of any software installations. You manage your own backups. They provide the physical hardware, the power, and the internet, and at rock-bottom prices. Let's see how the Ruby on Rails app breakdown looks when we're renting dedicated servers from Hesner. This is the Heroku. And on Hesner, we have 4 times the cores, 9 times the memory at 1/5 the price. For the database, we get the exact same specs for less than 1/10 of the price. And for Elasticsearch, we get 4 times the cores, 8 times the memory, 3 servers compared to 2 for 30% the price. For caching, it was about the same price, but for a lot more resources. Now, the price is $14,000 a year for significantly better performance and capacity. And the cores at Hesner are all top of the line and much faster on a per core basis as well. But this is only part of the story. Now, we have to manage backups, deployment, software installation and upgrades, security, failover, scheduled jobs, load balancers, pretty much everything. And this is what stops people from making a similar leap. This all seems very overwhelming, and when your company and your livelihood is on the line, it's natural to want to stay on the easy path with a solution like Heroku. The problem is, Heroku doesn't work for freemium apps. The majority of people who use StoryGraph do not pay for StoryGraph. Even worse, as we grew, the Heroku costs were growing faster than our revenue. If we stayed on Heroku, it seemed like we would never be profitable in the future, no matter what scale we grew to. We needed to make a change, and we needed an easy solution to help me manage that long list of tasks I just mentioned. Cloud 66 was and is that solution for us. They help with all of it, backups, deployment, software installation, the whole works, for about $10 a month per server. So $80 a month for the Ruby on Rails app that we described above. They essentially split out the front end of Heroku with all the convenience of one-click operations, and you just point it at your preferred backend. That could be a cloud service, the computer under your desk at home, or a dedicated server at Hesner. You have the flexibility to decide, and this is what made the migration off of the cloud possible for us. It's fair to say that without Cloud 66, StoryGraph would not be profitable today. So lesson 4, lean into self-hosting. For a growing company where millions of people use the product while only thousands of people pay, sustainability isn't optional. It's life and death. As a result, I'm a big proponent of self-hosting and using what you've got. And when I say using what you've got, I mean starting with your personal machine. Personal machines are extremely powerful nowadays, usually more powerful than the servers typically provided by cloud providers to run your app. And all of them are well equipped for self-hosting. When we first were getting started, this was a big part of our strategy, and even years later, with a more sophisticated setup, we never fully stopped. Now that I've properly figured out queues, I don't even need to open up any ports. Any machine at any time can join and leave the cluster, picking up jobs if it can. Even now, while I'm giving this talk, the GPU in this laptop is processing live requests from the app. You may have heard the phrase, unused RAM is wasted RAM. For me, that's an unused GPU is a wasted GPU. Going beyond jobs and queues, hosted services are the biggest win here. Once you see the efficiency of a $100 a month dedicated Hesner server, and once you're willing to step away from cloud services, a whole new world of options opens up to you. I'll give you a few examples of popular cloud solutions that we've started to self-host. On our scale, we simply couldn't afford the industry standard Mixpanel. Our website and app traffic put us in the contact sales range, which looked like it would cost us over $100,000 a year. Instead, we self-host the open source PostHog for $100 a month. Pricing was similarly expensive for the industry standard Datadog. Instead of Datadog, we self-host the open source Signas for $100 a month. Both PostHog and Signas, along with almost all other services I self-host, were all installed with a single Docker command. It was very easy. I understand that cloud services are the standard, and we've all normalized outsourcing key parts of our app to these cloud providers, and it never occurs to us that maybe we don't need them. That with some help from the documentation, we can run those services on our own for a fraction of the cost. If that idea has never occurred to you, I hope this talk inspires you to consider it. When things start to get pricey, look into self-hosting options and see what it takes to set up those services. It's probably not as hard as you think. As we know, AI is in everything these days. Every app has a box where you can chat with an AI, and it usually operates as a ChatGPT wrapper of some kind. But what's surprising is that as skilled and talented as we all are as software engineers, most assume that AI and ML is some sort of magic box that we couldn't possibly participate in without sending off all of our data off to some API. Most AI and ML implementations don't need anything fancy, and actually, it's the fancy stuff that usually doesn't match up with what your customers are actually looking for. Sometimes a simple machine learning solution is a lot faster, cheaper, and more fine-tunable than using a middleman API to solve this problem for you. When I first brought AI and ML to StoryGraph in 2019, I knew I wanted to host my own models for a few reasons. The first was privacy. I know that data privacy is very important to our community, and I wanted to guarantee that their data is safe with us. The second is cost. Why pay someone else to do what I can do better? The whole concept just felt wrong. So we've been self-hosting our AI and ML infrastructure right from the beginning, and it's worked out well for us. Right now, I'm self-hosting about a dozen or so machine learning models, things like book recommendations and finding similar users. Readers can upload book cover images to the site, so I trained a vision model to detect the probability of an uploaded image being an actual book cover to make sure users don't upload nefarious images or just poor quality book covers. Having many specialized custom models can take you a long way and are very easy to self-host. A year and a half ago, we released the StoryGraph Preview and Personalized Preview, features which rely on using a large language model to help readers determine if they like the book they're looking at. I spent 6 months working on just these two features, experimenting and iterating until I found a solution that both worked and wouldn't drain our bank accounts. This large language model is used pretty heavily. Every time someone loads a book page, it sends a request to a large language model. That's about 1 million requests on an average day, or about 10 large language model requests a second. Here's a live view of what that looks like. Each new line in what you just saw is a live request that was coming through and hitting the large language model. If I had simply uploaded our user data to ChatGPT, breaking our users' trust and compromising their privacy, it would have been easy, but not cheap. When I did the math on this, it would have cost us $70,000 a month to implement ChatGPT 4 in all the places where we use large language models today. We're self-hosting this at a fraction of the cost and without compromising the privacy of our users. This is the power of self-hosting and the beauty of taking machine learning into your own hands. So, in the weeks before December 31st, 2023, with our costs dramatically reduced thanks to self-hosting and our new infrastructure running, I was extremely confident. I had all the dedicated servers I would need, costs were completely under control. I was making jokes with Nadia saying our servers were so stable, we'll be playing VR ping pong together during the height of the spike. All the joking stopped on the morning of December 31st. traffic was way beyond expectations. And while traffic typically doubled at this time of year, this time it tripled. And it was clear that a core component of the app was not going to make it. I remember looking at Nadia and saying, tomorrow is going to be the worst day of our professional lives. Sometimes as a programmer or a DevOps engineer, the disaster comes fast, sudden, and it couldn't be predicted. But sometimes it's more like a hurricane. You see it in the distance, you know it's coming, you even know the date it will arrive, you just need to be ready. We were not ready. I was not ready. So in a way, it felt like I'd prepared my entire life for this. We were finally making it. We'd gone through outages, improved our technology, reduced our cost, but it wasn't enough. And for the first time, I genuinely felt like I couldn't do it. Mommy was wrong. Again. I got that feeling of being in college and being told I just didn't quite know enough math to succeed. It wasn't quite good enough. It wasn't just that I wasn't ready. It was that I had no idea how to get ready. And I had one day. As I said at the beginning, this is a story about the worst day in my professional life. And this is what it looked like. Hundreds and hundreds of angry tweets from users who couldn't get into the app, who couldn't reach their data, who were opening the app and seeing a blank screen. It was painful to watch. We genuinely did not know what to do. Who in the audience can guess which part of our app was being overloaded? My guess is the database. The biggest impact on Postgres was the large amount of Goodreads imports that was simultaneously being uploaded to the site. The first thing that many of our users do when signing up is upload their Goodreads file. On average, it's a CSV of about 1,000 books. So 100,000 people uploaded 1,000 rows each, so 100 million rows to import. But no, it's worse. Each row has about 10 unique pieces of information, so in all, it was about 1 billion inserts to handle, at the time when our app was already dealing with the most traffic it had ever had in its short history. Postgres was locking up, nobody can use the app, so we disabled Goodreads imports. Again, just like we did during the 2-week outage years prior. This worked for a few hours until traffic increased so much, there were so many people on the app, that even just reading from the database alone was causing outages. In desperation, we added a Ruby gem called Makara to the app, allowing reads from the Postgres replica. This worked great, and the app was up and running again for a few hours. We had so much traffic that the replication between the primary and replica servers got out of sync, which automatically disabled the gem, dropping us back down to a single database for reads, and the outage continued. In the end, we never figured it out. All my big talk about pushing through and persevering and never quitting and always figuring it out didn't work here. We tried, we gave it our best, and it just wasn't enough. Over the next few days, traffic naturally died down, either because people were frustrated and gave up, or because they got in and found a book to read already. It felt like our Super Bowl, the American Football Championship. You can see it coming, there's this huge event, everybody's going to be on your app, you make a plan, you prepare, and when everyone shows up, the power goes out. And I know this actually happened about a decade ago in the Super Bowl, and as a fan, I remember watching it and feeling bad for the workers, feeling like, oh man, this must suck for them. They're probably going crazy right now, and I didn't care that the Super Bowl was delayed for 30 minutes. But I'm sure for them, it was probably the worst day of their professional lives. So yeah, I understand that we're lucky, and our users love us. In fact, we somehow got good publicity out of this. But good publicity only lasts for so long. No one likes a prolonged outage. This was a humbling moment for me as an engineer, one where hard work wasn't enough. Instead, it was time that healed us, time that eventually gave us a fresh start and an opportunity to try again. So lesson number 5, time heals all. But there was also a very big technical lesson I learned during this experience that I'm going to show y'all in the hopes that no one here ever has to go through something like that. I'm going to spend the rest of this talk on my last tip, maybe my most controversial tip. Don't use Postgres. Yep, this is controversial, but hear me out. I spoke with a Postgres expert recently about this. He literally wrote the book on Postgres. He gives talks at conferences about it. In a situation where your Postgres database has gotten so big and is starting to slow down your app, his recommendation was to manually shard. It came with a big caveat though. Manually sharding your database is not easy and is best done with a database expert on your team. At the end of his pitch, I said, but YugabyteDB does that. YugabyteDB is an open source, Postgres compatible distributed database that is pretty close to a drop-in replacement for Postgres in your app. For a small team with 0 Postgres experts and 0 people equipped to manage a manually sharded database, YugabyteDB is the answer. At this point, and still today, the entirety of StoryGraph is 2 people, me and my co-founder Nadia. Think about the core components of a typical app. The web server, horizontally scalable. Elasticsearch, horizontally scalable. But your primary database, you just buy the biggest server you can find and hope it'll work. Because nobody, especially smaller companies, wants to deal with manually sharding their database. This is what sharding your database looks like. Sharding is splitting up your data from one huge monolith into multiple smaller pieces, then moving those pieces to other servers. Then when a query comes through, your app needs to know which servers have the requested data, and only those servers are touched. Doing this manually is very complicated. Keeping track of which data is on which server, sending queries to the right place, handling outages when one of the servers is down, this is not fun. A big advantage to Yugabyte is that it's a fork of Postgres. It handles all of the distributed database stuff while maintaining query compatibility. The query layer is forked, and the backend is swapped out for something that can natively handle horizontal scaling. This means that my Postgres libraries still work, and most of my Postgres queries are just as fast. We tested this for months, and we went live with a 10-server cluster on Yugabyte, with 960 cores, 2.5 terabytes of RAM, 40 terabytes of hard drive space, for $2,000 a month, about a third of the cost of a single Heroku database that we used to have. While all my queries worked, some, particularly those with joins, needed some modification. As an example, one particularly complicated query went from 100 milliseconds on Postgres to 400 seconds on Yugabyte. After modification, we got it down to 50 milliseconds on Yugabyte, and we found that it always has to do with some combination of these 3 factors to fix the query. 1, CTEs. Rewriting the query as a CTE allows Yugabyte to more efficiently split up the query into parts for separate servers to handle. Here's an example. This is a typical query that StoryGraph used to use, and this is the CTE version. It looks very similar, but the one on the left takes 22 seconds compared to 20 milliseconds on Yugabyte. This is as simple as copying the original query, pasting it into ChatGPT, and asking it to rewrite it as a CTE. I then test the new query on staging to see if it's faster and has the same output. When I say we live in awesome times, this is what I'm talking about. I have no idea what it would have taken for me to convert the query on the left to the query on the right before ChatGPT. But I know it wouldn't have been fun. And we had to do this with dozens and dozens and dozens of queries. 2 is adding more indexes. An index in Yugabyte is a new table that reorganizes the data so it's easier to find. For example, if your query is looking for all the book IDs by a particular author, the index would sort the books table by the author's name in alphabetical order. Without the index, you'd have to look and specifically check each row to see if the author's name matches the author you're looking for. While inefficient, this still might be fine when all of your data is on a single Postgres server, but when it's distributed amongst 10 servers, this is a big slowdown. When using the index, you could skip directly down to where the author's name appears in the table, and all of their books will be clumped together. For example, if you're looking for all of Evan Winter's books, you can skip down to the E's and quickly find the first Evan Winter entry. Then you can go down one by one until you see the first name that's not Evan Winter. In this case, it's Frank Herbert. Once you see Frank, you can be confident that there are no more Evan Winter's entries anywhere else in the list because it's in alphabetical order. The hard work was already done for you. I found that due to its distributed nature, I've had to add a lot more indexes on Yugabyte to keep my queries efficient. But that's okay. Adding too many indexes is only a problem when it slows down your ability to write to the database. And with 10 extra servers, the extra capacity gained far outweighs the slowdown of adding extra indexes. Number 3 was denormalized tables. I think of it like this. A denormalized table is an index that can organize data from multiple tables. That's it. Imagine we have a books table, a users table, and a reviews table. Normally, if you'd want to find all the authors that user has left reviews for, you'd need a join query. First, it will find Rob's user ID in the users table, then check the reviews table to find all the book IDs that user has left a review for, then search the books table for those book IDs to find the author for each book. That's a lot of steps. And if you've read hundreds or thousands of books, it can take time to find all the entries across all 10 servers. With the denormalized table, the relevant columns are put side by side in the same table. Now the query goes from this, with multiple joins, to this. Much more efficient. The downside is you need to manage the denormalized table manually in your code. Anytime a user leaves a review, you need to update the denormalized table too. When a review is deleted, you have to delete it from the denormalized table too. But this is doable, and if you use Ruby on Rails, Rails triggers are an easy way to manage that. So if you're dealing with a large Postgres database that you need to shard and you don't have the experience to do it, look into Yugabyte. So I gave this talk at NDC Porto back in October. And this slide is pretty much where I ended it. I had my master plan for getting through January 1st, 2025, with self-hosted servers with YugabyteDB and denormalized tables. So how did it go? It went okay. In November, about a month after my talk, a few TikTok videos went viral about us, and more people than ever were visiting the site. For context, a year earlier, we were seeing about 150,000 unique visitors to the app every day, and suddenly it spiked up to 1 million. And the site was crashing again. I went through my checklist, and after many hours, I found the bottleneck. The HA proxy server that was load balancing all the YugabyteDB requests had completely saturated its network. CPU usage was low, but the network connection simply couldn't handle any more traffic. So I took what I think is a completely reasonable next step, and I just installed HA proxy on all the web servers. And I told them all to connect to localhost on the HA proxy port to get to the database. Now, any network engineers in the audience might think this is crazy, and you might be right. I don't know, it works. But I saw another potential bottleneck coming up. The number of database connections being used was higher than I expected. I usually address this by using PG Bouncer, which is a database connection pooler that allows your app to reuse existing connections, allowing you to scale more easily. With 10 servers, I didn't think I would need it, but I did. So I installed PG Bouncer on each web server, which points to the local HA proxy, and the topology ended up looking like this. And the bottleneck was removed. Immediately, everything was fast again. But that experience scared me. It seems like whenever we reached a new threshold of traffic, new bottlenecks came up that were nowhere near being close on my radar. And January 1st typically has many, many times higher traffic than a typical day. If a typical day already has 1 million people accessing the site, what is January 1st going to look like? So I preemptively scaled up the servers. 10 web servers and 60 databases. I didn't want to draw all 600 lines here, but you get the idea. In the weeks leading up to January 1st, I was feeling good. No, I was feeling cocky again. I posted a video to TikTok, which would be our most watched video ever, explaining that yes, StoryGraph has been failing you. Every January 1st, the app goes down right when you need us the most. But this year will be different. We were actually ready. So our experience on January 1st, 2025 really highlights the challenges of having a small team. In the last few weeks of the year, as traffic started to increase, we were getting more and more messages from users explaining that they either couldn't open the app at all or that it was super slow, as in 3 minutes to load the homepage slow. The vast majority of people, me included, had no problems at all. Now, I have 15 years of experience troubleshooting enterprise, network simulation, and monitoring software, so this seemed like a simple one. I went through my checklist. Now, if you can, put on your troubleshooting hat, put yourself in my shoes, and go along on this journey with me. The information to solve the problem is in the coming slides. Can I reproduce the issue on any of my devices? No. I tried iOS, Android, Linux, Mac, Windows, Firefox, Safari, Chrome, Chromium, Brave, Vanadium, connecting from different states, different countries. It was always fast. Can any of my friends or family reproduce the issue? No. Does logging in as an affected user cause the problem? No. Does using a VPN fix it? Yes. Okay, we're getting somewhere. Does changing DNS with Rethink DNS fix it? No. Does switching to Wi-Fi or mobile data fix it? Sometimes. Does using a mobile browser instead of the app fix it? Sometimes. Does using a new desktop browser fix it? People were sending me videos where one browser would be completely unable to connect. Then they'll switch browsers, and it would load immediately. In the interest of time, let's skip ahead here, but I'd like to call out a few of these points. Having them use a hidden internal link that had nothing to do with StoryGraph always worked. The problem randomly fixes itself in about a day, about half the time. And I found a Cloudflare forum post with exactly the same issue, even calling out that nobody in the Philippines could connect, but the fix of disabling the Cloudflare proxy didn't work for us. 24. Does the HA proxy load balancer have the same weights for all the servers? It did. This is the dashboard. It's probably too small to see, but the weights for each server, which tells the load balancer how often to send requests to each server, is set to 1. So there doesn't seem to be an issue with the load balancer. Is the app running on all the servers? Yeah, I had SSH to each server, and all the Ruby processes were there. Many were at 100%. The HA proxy and PG bouncer processes were active too, so clearly it's doing stuff. The first 2 web servers had a higher CPU usage, around 60%. But those have some monitoring software manually installed that the new servers don't have, so maybe it's related to that. Either way, 60% should be fine. 26. Is PG Bouncer limiting the number of connections? Now, January 1st, 2023, so 2 years earlier, it was a PG Bouncer misconfiguration that caused the January 1st outage. The database could handle 500 connections, and PG Bouncer was set up to handle 10,000, but there was a setting, the default pool size, that limited each username and database pair to only 64 connections. All of our connections use the same username database pair, so changing this to 500 solved the 2023 outage. But this time, I checked every single PG Bouncer and every single HA proxy, and the stats showed no such limit was occurring, and no queries were waiting for an open connection. Finally, I said, similar users isn't working. Could that be causing it? Whenever someone clicks on the Community tab, the app hits a machine learning API that I'm self-hosting that loads up similar users that you might want to follow. This can take a few seconds to load, and right around the time that people were having trouble loading the app, it stopped working. It didn't load in time, and the app showed no similar users. Is it possible that so many people were waiting for their similar users to be processed that all the available connections were just sitting around waiting for something that would never finish? Well, why the heck wasn't similar users working anyway? Every time I check the queue, it's at 0, so incoming requests were being processed pretty much immediately. A deeper dive into this showed that the process which adds similar user requests to the Redis queue was overloaded. Shifting more resources to the manager solved that problem, but did that fix the site slowdowns? No. So what the heck is going on here? Was this really just out of my hands? Was there an unrelated network issue that would just solve itself if I waited it out? Are we really about to have another January 1st where I just couldn't figure it out? Was I missing something? January 1st arrived, and the issue was growing. We have 60 YugabyteDB database servers at almost 0 CPU usage, 8 of my 10 web servers were at 7%, and more people were complaining that the app is slow. I couldn't believe it was happening again. I stared at my computer in disbelief. So I took a step back for what must have been the 30th time, and I took in all the information, and I tried to think through it. Before I continue, any guesses what the problem was? Yeah, I had nothing either. Before I said that already. So I stepped back to reflect, and I thought, if my app is slow, why aren't the queries slow? This reminded me of the PG Bouncer issue from 2023, where connections were being limited to 64, and the similar users issue, where not enough manager processes were being added to the queue. In both situations, the process server was operating very quickly, and the key was figuring out why the requests weren't getting to it, which brought me to my last question. Are we running out of Rails threads? Are there so many users hitting the site that even though the web server CPU is in the single digits, There simply weren't any threads available to process incoming requests. I might need to adjust the web concurrency and the Rails max threads environment variables. Well, how many requests is each server handling now? This led me to looking at the HA proxy dashboard more deeply, and what the heck is that? HA proxy showed 700 to 600 sessions on servers 1 and 2, and only 20 sessions for the rest. Nadia and I were in the middle of an all-nighter. I hadn't slept yet, and it was already 5:30 p.m. the next day, 1:30 a.m. for her, but I was onto something. So what the heck would cause HA proxy to do this when the wait is set to 1 for each server? I opened up the configuration file and I saw it, right there staring me in the face. Cookie lsw_web. A quick search indicated that this is a HA proxy setting for session persistence. It keeps you connected to the same server for your whole session. And it clicked. I opened up Firefox, checked my cookies, and there it was. A cookie pinning me to server 2. All the troubleshooting I was doing, asking people to try different browsers, devices, networks, whenever it actually worked, all I was doing was changing their session. And there was an 80% chance that they would be assigned to a new server which wasn't overloaded with sessions. This was it. I deleted the cookie setting in HA proxy, replied to the most recent person who emailed us, and crossed my fingers. 4 minutes later, I got this. Wow. Okay. So it seemed like most of this talk is just posts of people angry at us, specifically angry at me. But I really learned something from this latest January 1st outage a few weeks ago. It's okay to have outages. Even more, if you're having outages, you're probably doing something right. Apple, Meta, Microsoft, all the big tech companies have outages. When you reach new heights, whether it's 100 users or 1 million, things are going to happen that you just couldn't predict. This is part of the game. When that happens to you, I hope you remember this talk. We as software developers are in a privileged position to have people who care so much about our product, about what we're building, that they're angry when it's down. And I'm grateful for that. Whenever I see talks like this, I can't help but think of the speaker, yeah, well, of course it worked for them. Otherwise, they wouldn't be given this talk. That doesn't mean I personally can do this. But I hope you can see that I'm just like you. I didn't have access to any special secret sauce. I didn't have the degrees or the training to guide me. I got very lucky in my timing with AI helping with coding, GPUs being powerful enough for personal custom models and self-hosting, and software reaching maturity when it did with AI and Yugabyte. If we tried using Yugabyte just a year earlier, it wouldn't have had the features we needed to go live. With all of the open source tools available now, it truly feels like we're standing on the shoulders of giants. And a lot of that luck applies to anyone sitting in the room right now. We are all lucky to be in tech today, in the age of AI and in the age of self-hosting. What I have is the perseverance to not quit until I figure it out, and a high threshold for pain. What I have is the ability to stare at a technical problem and brute force my way through it, no matter how long it takes. To win at this game, you don't need to already be the best. You just need the will to do what the other guy wouldn't. To be creative and audacious in your problem solving. My biggest asset is I truly believed in Mommy's words. I really do think that I can do anything, and that's helped me do a lot. And that's how we've grown StoryGraph to 300 million monthly requests with a one-man AI DevOps team. Thank you.